All right, and I've got to turn Lily's down all the way or I'm going to go nuts.
No, it doesn't. It names it can be whatever it wants. And like my name is Ezekiel.
Okay. All right, guys. Ah! This board, someday I'm going to get the hang of it, I swear. Okay, so yesterday we were talking. I have a trash can right here. All right. Yesterday we talked about fractions, and we have numerators and denominators, and we learned that
Numerators are on the top and denominators.
numerator is this guy on top. Denominator is this guy on bottom. That's bad handwriting. But when I look at these numbers, the numerator and the denominator, what do they tell me about a fraction? What does the denominator, let's start with the bottom. What does the denominator tell me? Josie, what does the denominator tell me?
It's the whole thing.
It's the whole thing. How many pieces is the whole thing? So in this situation, I might have a pie that has 8 pieces, okay? And then what is the numerator on top telling me, Sophie?
How much you should?
How much I have of that whole thing, right? So 7, 3, 4, 5, 6, 7. Yes, Zeke.
On that chart, it looks like you got it backwards because the total number of parts should be on the top, right? And
No,
then
the total number's on bottom. There's 8 total pieces. How many parts I have is on top. That's right.
Okay.
Total number's on bottom. Okay? So yeah, the bottom number, that denominator, is the total number of pieces that I have all together. Okay? Now, yesterday, we talked about, when I made this chart that's way over here now, we talked about something called an improper fraction. And an improper fraction, sorry, my handwriting is still learning how to be handwriting on here. And I want to change to black, I hope. Okay. Improper fraction is a number that looks like this. The big number is on top in the numerator spot. So now that means I've got 8 pieces, but a whole thing only has 7. So I have more than one whole thing. So let's look at what this picture might look like. So I've got, hang on, I don't want to do that. I want to make it a square. It's easier for me to make 7 pieces if it's a square.
That was a good circle.
Well, we'll do a circle later, okay? All right. So I've got a rectangle, and I'm going to give it 7 pieces. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. They're uneven, but that's 7 pieces. We're pretending they're even, okay? But it says that I have 8 pieces.
So you gotta make 2 pictures.
So Lily says I need to make 2 pictures then.
And then just scribble it.
1, 2, 3, 4, 5, 6, 7. All right, that one I did a little bit better job. All right, so in this scenario then, in this example, if I can get it to change back to red, which it doesn't want to. Any other color than black, thank you. All right, I got a color in 7. So I got 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 pieces out of 7. So I've got one whole thing
And 1 and 1 7.
and 1 left over. So I've got one whole thing, and then I've got 1/7 left over. Does everybody see?
Yeah. So is that
Okay.
a mixed number then?
Okay. And so then this one, the one on top that's in black, is what we call the improper fraction. And then the one on bottom is called a
Mixed number.
mixed number or mixed fraction. Either one works. Okay. Now, we need to be able to go back and forth between these 2 ways. We need to look at an improper fraction and be able to see what that means as a mixed number. That's what we're going to be working on today.
Oh, yeah.
So, when we do that, the first thing I want to tell you is this other fancy word that I have.
Fancy word.
Okay? And I'm going to erase my picture.
You know you can like
Hang on.
Can you not click on the TV?
Oh, there's.
No, I can't touch the TV. The TV doesn't touch. That's
What
okay.
about you can what about the spray bottle?
I don't want a spray bottle.
It erases everything.
I don't want to erase the whole screen. I just wanted to erase part of it. Okay. Now let me go back to my pen. Okay. This 8/7 and 1 1/7, they are the exact same amount. They are equal. And there's a fancy word when two fractions are equal.
Oh, equivalent.
Equivalent. High five, Sean. So the big fancy word, equivalent. I'm going to try my best to write this nicely. Equivalent means equal. They're the same. These are equivalent fractions. That means they are the same. They both mean I have one whole thing and 1/7 of another thing. Okay? All right, so now let's look at how we can figure this out without necessarily drawing a picture every time. I'm on brown, and that's just what I'm going to be on. Okay? And so if I were to have, let's see here, 5/4. Let's start with an easy one. Okay? So I got the number 5/4. I want to look at my denominator, my number on bottom. And I want to see, because what would one whole thing be? 4 pieces, right? So 4/4. 4/4 would be one whole thing, right? Okay. And I've got how many more than that? One more. So I've got one whole thing. So when I look at this, what I can do is take that bottom number, my denominator. You guys can't see when I do this. My bottom number, my denominator. And then I'm going to see how many times does it fit inside my numerator. So I can put a 4 inside of 5 one time, one whole thing. And how many were left over would I have? One. So the equivalent fraction here would be 1 and 1/4. Let's do another one. Seems simple enough. What about 8/3? How many times, I'm going to look at my bottom number, my denominator, how many times can a 3 go inside of 8?
2.
A bunch of people are shouting out 2. What is 3 times 2?
6.
6. So I've got, 6? No, lies.
2.
2. I've got 2 whole things. And 2 whole things would give me 6 pieces. And how many do I have left over?
2.
What is 3 times 2?
6.
6. So, but I have 8 pieces. So how many are left over?
2.
2.
2.
2 and 2/3. So let's double check this. How could we double check this?
Multiply the piece.
All right, here's one simple way I can check it. I can draw a picture. All right, I have 8/3. Does everybody agree that I have some little pies cut into 3 pieces? And I need 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. I have 1 full thing, 2 full thing, and 2 1/3. 2 out of 3 pieces cut here. So I've got 2 and 2/3. Okay, does that make sense? Okay, so basically what we've got to do is divide the top by the bottom. So let's try another one, if I can get this to clear. All right.
9 and 36. Now it's even. 9 and 7.
26/5.
Oh, 5 times more.
How many times? 26 divided by 5. How many times can I get 5 into 26?
5.
Sophie, how many? 5 times. What is 5 times 5?
25.
25. But I have 26.
5 with.
So how many are left over?
One. So what? 5 and
Kendall says 1. And I use that same denominator, 1/5. So 26/5 is the same as 5 whole things and 1/5 left over. Lily.
Can you give us one and we can do it on our whiteboards?
Yes. So let's practice one now. If you guys have your whiteboard or you want to type in the chat, you can. I'm going to give you one and then you guys show me you can do it.
I don't have a board.
You don't have a marker?
I don't have a whiteboard. My whiteboard needs to be.
You don't have a whiteboard? Okay. Are you ready?
Yes.
Yes. Wait.
Zeke, yep. Sam, yep. Yep. Josie, yes. Fiona, hang on. I got to look back at the chat.
Just keep chat open.
Yes, Fee. Yes. Who is that? Cam, yes. Kendall, yes. 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 That's fine. All right. So how many?
51.
But you got color in it. So can you fit
Do 50. Do 51.
Oh.
51 10.
After I trip and almost die, Macy almost killed me. I tripped on her backpack, but I made it close. You don't need this because that would make it 3 whole things. Okay, so here's what I saw from some of you. Most of you gave me a this. How many times can 4 go into 8? 2. I saw some of you do this.
You don't need that.
And 0/4. You didn't have anything left over. But guess what? Do you need to write 0/4?
No, because there's nothing else.
It's nothing. It literally means 0. So you don't need to put that.
It just
If you did it, it wasn't wrong. You just don't need it. Make sense?
did a little extra.
You gave me a little extra. Okay? So let's try another one. Good job, guys. Yep. No. Check your fraction. Yes. Josie, yes.
Now I have it.
Yes. Yes. Yes, 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 yes. Anybody else? Cam, yes. Boys, are you participating? Are you there? Because I'm not seeing any answers from Lucas, Kane, or DJ.
I'm here.
Okay.
Look at the chat.
Yes, yes. Good. Good, 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 guys. All right. 11 divided by 7. How many times can 11 go into 7?
1 time.
1 time. And how many leftovers would I have?
4, 7.
4 left over. Put that over the same denominator. 1 4/7 is the, what do we call it? What's that fancy word?
Equivalent fraction.
Equivalent fraction. Good. Okay. All right. Let's do.
Are we doing these until recess?
No, you're going to have a worksheet to do on your own.
Oh.
Wait, can we have it now?
Okay.
So we still have time.
That's why I just.
Careful. Check your fraction. Yes. 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 Josie, yes. Cam, yes. Yes. Max, do you have it? Yes. Yes. Fee, yes. No, check your numerator again. Yep. Yep, Kendall, you got it. All right. I think almost everybody. There you go. All right. 8 divided by 5. No. How many times does 5 go into 8? One time.
3 is left.
And then 3 is left over. Because one set of it would be
1 3.
5/5 would be one whole thing. But I have 8/5. So I need to take 8 and subtract that out. So 8 minus 5 gives me 3.
There's 3/5 left. 1 and 3
Okay.
fifths.
All right. Yeah.
Instead of dividing first, I subtract. Like I subtract.
You divide
see,
first and then
I'm saying-
subtract.
So is that the right way to do it?
Okay.
Or use multiplication.
What am I talking about? Watch, I'll show you. Okay, another one. Ooh. So first step, divide your top and your bottom. 72 divided by 10. How many times can 10 go into 72? 10, 20, 30, 40.
What's that?
Okay, yeah.
Where'd she mean it? 72 and 6.
Fee, we're missing a denominator. Yes. Yes,
got
Joe.
enter button. I was gonna
Oh, okay. Then you were right. If you were just missing the yes.
yeah, then I was gonna do /10. So
Yes, Cam, you got it. Boys, are you doing okay? I don't know what you got going on over there. Nobody's responding. I don't know if you guys are alive or not. They're sleeping on the job, I think. Not really sure. DJ's at least talking to me. Yes. All right, so step 1 is that we divide. And when we do that, 72 divided by 10, we know that 10 goes into 72 7 times. That gives us our whole number. And that tells me then that I would have 70. 10 whole, or 7 things that were 10 and would be 70. I would have 2 left over. Okay? 7 and 2 tenths. Okay? Make sense? How's everybody feeling about this? 1, 2, 3, 4. 4 is awesome. Give me the worksheet. I'm done with it. This is amazing and easy. I've got people giving me 10. Kane is 9,999. He beat all of you. Okay, I like some honesty over here. Whoa, Fiona's feeling froggy too. Okay, all right, I've got a couple people that are still probably hanging out somewhere around a 2. So let's do a couple more before I give you your worksheet, okay? Okay, I'm going to try and stick with something easy-ish.
No, do something hard, like 72 and 6.
All right, 13 divided by 2. 13 halves. How many times can 2? Ooh, no. Yes. How many times can the 2 go into 13? 2, 4, 6, 8. Yes.
Yeah. What did you do wrong, Sam? What did you do wrong, partner?
I mistaken for 3.
How many times can 2 go into 13? Yes, Kendall. Where'd Josie go? Yes, Fee. Yes, Josie. Yep, Kay. Yes. Okay. So we're going to count 5, 2, 3, figure out how many times. And that gets you that we use 2 6 times. What do you think we get? 12. So what's the difference between 12 and 13? All right, we're gonna do
One more.
one
No more.
more.
Just one. I want worksheet. 3,000.
Yep, Kaylee. Yep, DJ. I missed your answers, but yep. Okay, it was. How many times? 6 and a half.
Like right out of division problems.
Because check this out, guys. Just again for the people that aren't 100%.
What?
Hang on.
I think you're on 13. That's only 7. Sort of, I guess.
I know, that's all I need. Okay. The 2 tells me I've got stuff that's divided in half. Right? So I went ahead and I drew a bunch of pies and I divided them in half. And it says I've got 13 pieces of this half pie. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So how many whole pies did I end up having? 1, 2, 3, 4, 5, 6 whole pies and a half a pie left over. Okay? Does that help make sense drawing the picture with it? All right.
Are we doing another one?
Yep. Cam, yes. Yes. Josie, yes. Okay. Kendall, hang on, hold it back up, Kendall. I didn't see it. Yes. All right. So again, if you're not sure, the 3 on bottom tells me it is something that's divided into 3.
Triangles.
I don't know how many triangles I'm going to need. I'm just drawing a bunch. And they're divided into 3. I don't really know how I'm dividing these triangles into 3. I guess I'm doing it like this.
That doesn't work.
They're not even, but it's okay. We're pretending that they're all equivalent. All right, and I need 12 pieces. There's 3/3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces colored in. I have 1, 2, 3, 4 whole things. Do I have any left over?
No.
No. Okay, so it's just 4 holes. All right, guys, let's see how you do with it. I'm going to give you a worksheet. You guys have a worksheet. You can start working on the worksheet, and I will see you at 10:35 for science. Bye. Bye, guys. Bam.
My whiteboard is pretty clean.
I've got a spray. Hang on just a second. Let me turn this off.